Hello, hi. Welcome back. Welcome back to EDUHUNT IIT Foundation classes. This is Sukumar, your chemistry mentor. Now we are in 6th class Foundation Chemistry and the chapter name is Symbols of Elements, Ions and Formulae. We completed the theory part. Now in this video, I am going to explain or I am going to solve the worksheet questions. Okay, but my suggestion is to you first complete the theory videos. After watching the theory videos, you attempt the worksheet by your own first. While attempting the worksheet, you may feel some difficulty or you may get some doubts. No problem. Move on. Complete the worksheet. Okay, mark the questions where you feel difficulty. Mark those questions. Okay, solve the rest of the questions. Complete the worksheet by your own. Then come to watch this video. Okay, in this way you will be very benefited. Okay, yes, I hope you do so. This is worksheet number 3, mains model. Yes, without wasting time, I am attempting the question. Question number 1. The chemical formula is a short form of representation. Chemical formula is a short form of representation of a compound. Yes, CaCO3. This is the short form of this formula. This is a formula. Okay, this formula is a short form of representation of the compound called calcium carbonate. Like that, H2SO4. Okay, H2SO4. This is the short form. This formula is the short form of representation of the compound called sulfuric acid. Yes. Moving towards next question. Which of the following is perchloric acid? Okay. I hope you covered that theory part given in the module. What is about chlorine, oxy acids of chlorine. Oxy acids of chlorine. Oxy acids of chlorine. Okay, sir, what it means, sir? Why this particular name called oxy acids? See, generally what happens, acids, there is a particular type of acids called protic acids. Sir, we don't know that, sir, no problem. Generally acids, in general acids releases H+. Acids releases H+. But in these acids, that H+, that means hydrogen, the releasing hydrogen or the hydrogen which can be released is present on oxygen like this. So this bond is present, okay? But do remember, wherever this bond is present, all of them are not acids, okay? Yes, you will get this clarity in the upcoming chapters, okay? Yes, because sometimes if you see this OH, that can be alcohol also. But the point is, alcohol also can behave like alcohol, also have some acidic character. You will learn this slowly, okay? But the point is, what is oxy acids? See, the oxy acid means the acid in which the replaceable hydrogen is present on oxygen. Oxy acid. Okay. Now, what are the oxy acids of chlorine? The first one is HClO4, HClO3, HClO2, HOCl. Okay, see the difference? Here we wrote that oxygen in the middle. It doesn't make much difference, but see this. Is it easy? Is it not easy to write like this? HClO4, HClO3, HClO2, HOCl. The first one is perchloric acid. Perchloric acid. Okay, sir. Okay, sir. What is the next one? Chloric acid. Chloric acid. And then next one, chlorous acid. Chlorous acid. What is the last one? Hypochlorous acid. hypochlorous acid. chloric, perchloric, chloric, chlorus, easy, HClO4, HClO3, HClO2, HOCl, okay. You don't need to learn the structures or their geometries or their shapes in this 6th class foundation, but to give a little bit feel about the subject, I am drawing for you, okay. HClO4, Cl, okay, chlorine, double bond, double bond, double bond, okay. The point is, one OH, oxygen, oxygen, oxygen. This is HClO4. Similarly, chlorine. Okay, 3 oxygens, 1 OH compulsory. Then rest of the 2 oxygens, double bond O, double bond O. Okay. What about this part? 2 electrons left like this. So you are not supposed to learn this. You are going to learn this in upcoming chapters like chemical bonding chapters. Okay. Similarly, HClO2, chlorine, 1 OH compulsory, another oxygen, double bond. So as you remove the oxygen, you put 2 electrons, that is the electron pair, okay, like this, electron pair, like this. And the last one, oxygen, wrote like this, hydrogen. The point is, in all of them, all of them are acids. What type of acids? All of them are acids. Why acids? They release H+. Okay, sir. What type of acids? Oxyacids, because that releasing H is present on oxygen. Oxyacids, 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 perchloric acid, chloric acid, chlorous acid, hypochlorous acid. I hope you got this. Now, the chemical formula of potassium superoxide. Okay, I told this, I explained this in the theory video also about oxygen. See, oxygen when gained 2 electrons, it will become O2 negative. This is oxide. This is oxide. Sometimes, in few examples, 2 oxygens will gain 2 electrons. Each 1 electron. Okay, there is 2 electrons. Together, they gained 2 electrons. There is 2 oxygen. These 2 oxygen together gained 2 electrons. Then each one get 1 electron. Okay, fine. That is nothing but a peroxide. Peroxide. I hope you remember how a anion is formed. I explained na how. Anion is formed by the gain of electrons. So obviously, here 1 oxygen atom gained 2 electrons to become oxide. Here 2 oxygen atoms gained 2 electrons to become peroxide. And there is 2 oxygen atoms, but together they gained 1 electron only. Together they gained 1 electron only. That is superoxide. Actually, most of the compounds, most of the oxygen compounds are oxides. Oxygen will be mostly present as a oxide form, sometimes as a peroxide. Okay, I'll give you examples. CaO, calcium, calcium oxide, magnesium oxide, sodium oxide, potassium oxide, aluminum oxide. All these are oxides. So most of the compounds of oxygen, binary compound. That means 2 elements only. When there is 2 elements, in that 2 elements, 1 element is oxygen, then you can say binary. Binary means 2 elements. Okay. One of the element is oxygen. It will be mostly oxide. Oxygen will exist as an oxide form mostly. Some examples, it will be existing as a peroxide, like sodium peroxide, hydrogen peroxide, antiseptic, famous antiseptic. Hydrogen peroxide, barium peroxide, like that, so many examples. Okay, but compared to this will be less examples you will find. That was very rare, very rare. In our syllabus, you will find at one place only, that is potassium superoxide. That which family? Alkali metals na? Lithium, sodium, potassium, rubidium, cesium. potassium superoxide, rubidium superoxide, cesium superoxide. These are the three examples, only three examples where you find oxygen in superoxide form. I hope you are getting this. Yes. Moving towards single correct, level 2. Okay, fine. A metal M forms a compound M2HPO4. M2HPO4. Okay, fine. What will be the formula of the metal sulfate? See, you have been given with a formula called M2HP. I'll write here. M2HPO4. So, this formula is given. In this formula, cation is a M, it is a metal said in the question, and HPO4 negative is the anion. So, formula given to you, and we been asked to answer, if this metal forms sulfate, what will be the formula? If this metal forms sulfate, what will be the formula? See, but I hope you remember the process of writing the formula from the ions, right? Crisscross method. In crisscross method, you have taken ions and raised their charges and crisscrossed their charges to get the formula, right? Yes. Now, in this way, I am going to reverse the process. In crisscross method, what we did, we have ions and we crisscrossed to get the formula. Now what I am going to do, I have formula, I will reverse the crisscross process to get the ions. So first of all, I will give the crisscross method once again for you. For suppose, if you have a ion given like this, M plus H, HPO4 minus, what you have to do? You have to raise the charge, okay? Like it is -1, it is +1, okay? It is the paperwork, you may or may not erase after here, no problem, okay? You raised the charges. Then after that, what you did? You crisscrossed, right? Because the charge present is M. Then how many these ions you have to take? You have to take this one, 1 HPO4. This is also 1 M. That's why M 1 only, HPO4 also 1 only. That's how this formula formed. No. Okay. Okay. I have taken wrongly the charge. The charge present here is -2. The charge present here is -2. -2. So it will be -2. So how many M you have to take? You have to take 2 M. So M2HPO4 is the formula. Okay? Yes. So with the help of this concept, now if I am going to reverse the concept, because you have formula now. You have formula. What it means? You have formula means this 2 came from where? Where this 2 came from? This 2 you got, actually this 2 in the formula. This subscript in the formula came from here. Now. This is actually the charge present. So what happens? The subscript of the cation is the actual. From the subscript of the cation, you can guess the charge on the anion. So the point is, separately write M and HPO4. And what is the subscript of the cation? 2. That means 2 unit negative charge is present on anion. What is the subscript of the anion? No, nothing. HPO4, no subscript. Okay, that means 1 HPO4, because the charge on the metal is +1 only. The charge on the metal is +1. Then how they will be balanced? This is 2 negative, this is 1 positive. Yes, you have to take 2. So this is how you got the clarity about the cation present here. Now the question is asking, what will be the formula of the metal sulfate? You know sulfate? Sulfate is SO4 2 negative. And you know this metal is M plus. How they has to be balanced? 2 negative has to be balanced by 2 positive. Then take 2m. Then make the formula. M2SO4 is 1 only. M2SO4. That M2SO4 is the answer. Okay? Yes, we are going to get the similar questions in the next also. Which of the following is not the correct formula? Yes, H2S correct formula. HSO4 minus Na plus. I hope you memorized it. I hope you got familiarity with the anions, anionic radicals. Okay, HSO4 minus. And SiO2, silica, ఇది ఇసుక sand, SiO2, silica అంటారు. ఓకేనా? ఇంకో జనరల్గా ఇలా అర్థం చేసుకోవాలి. SiO2కి ఒక ఆక్సైడ్ యాడ్ చేసాం అనుకోండి. జస్ట్ పేపర్ వర్క్. SiO2కి ఒక ఆక్సైడ్ యాడ్ చేసి, you add one oxide, then you will get SiO3. See, it is neutral. For the neutral species, you added O2 negative, then the 2 negative will be there only. So SiO3 2 negative. SiO3 2 negative. Then how to balance with the cations? So if I have to supply sodium Na plus cation, SiO3 2 negative. So to support this anion, how many Na plus I need to take? 2. Then the formula will become Na, how many sodium? 2. Subscript 2. Silicate, SiO3 2 negative, how many of them? SiO3 1 only. I hope you got this. Okay? Correct formula. Not correct formula, we need to find. Yes, we got Na2SiO3, but in the question given NaSiO3, that is wrong. The correct is Na2SiO3. Next, which of the following is not the correct formula? Again, same kind of question. CO3 2 negative. I'll write CO3 2 negative. So how many units of charge? 2 units of charge. Hydrogen is H plus. How many units of charge? Okay. So that means you need to take 1 carbonate and 2 hydrogen. Okay. That means H2CO3. Correct. Like that. Al3 plus Cl minus. How many units of charge? 1 unit charge. How many units of charge? 3 units charge. You need to take 3 chlorine and 1 aluminum. That means AlCl3. Correct. Sodium carbonate. CO3 2 negative. Na plus. First you have to be familiar with the ions like this. Carbonate, CO3 2 negative. Sodium Na plus, like that. How many units of charge? 2 units of charge. How many units of charge? 1 unit charge. You need to take 1 carbonate and 2 sodium. How to express 2 sodium? As a subscript you have to write 2. CO3 2 negative is 1 only. See, that is a polyatomic. But polyatomic only 1 present, so no need subscript. For polyatomic, if you want to use the subscript, you have to keep the bracket like this. But here 1 only, no need of bracket, no need of subscript. Okay. Then I hope this is the wrong answer, because carbon dioxide has no charge. Then how it will combine with 2 positive charged sodium ions without charge? So that is the compound which is not existing actually. Next, formula of chromic acid. Formula of chromic acid H2CrO4. Then the formula of divalent metal chromate. See, the point is chromic acid H2CrO4. We know very well hydrogen is H plus, and how many hydrogen? 2 hydrogen. That means total 2 plus. It means that chromate anion they are saying has 2 unit negative charge. Na? You can guess like that. Because there is 2 hydrogen. Cation is hydrogen. Hydrogen is always H plus. There is 2 hydrogen, means 2 units positive charge. In any compound, charge has to be ultimately balanced. So the positive charge present on the cation must be equal to the negative charge present on the anion. Okay. Now what the question is asking about? Question is asking what will be the formula of divalent metal with this chromate? That means metal chromate, like magnesium chromate, zinc chromate, like that. But the metal they are saying is 2 positive. Of course, so divalent means 2 positive. Divalent cation means 2 positive, divalent anion means 2 negative. Okay, then this chromate also CrO4 2 negative. How many units of charge? 2 units charge. How many units charge? 2 units charge. How many M you have to take? 2. But the point is, both are divisible by common number. So you have to reduce this to divide this with 2. Then one metal CrO4 2 negative. See, this is at the beginning level. So after you are getting some clarity, it's very common sense, basic common sense that 2 unit negative charge, it has to be balanced by 2 unit positive charge. Therefore, one metal atom can combine with one chromate ion. So simple, no need to do that entire crisscross. It will be a time lagging. But at the beginning level, you can do that. Okay, of course you are beginners. MCrO4.